Today we're going to kind of do another skill that we did on Wednesday, similar to what we did on Wednesday. So Wednesday, a few days ago, I taught you guys how to find the determinant. Try again. The determinant. Do you remember that word from 2 days ago? Okay. So if I make up some numbers here, I'll just keep it simple. 1, 2, 3, 4. Do you remember how to find the determinant? 1 times 4 minus 2 times 3. Nice. That's how you find the determinant. You're going to need that skill today when I teach you how to find the inverse matrix. Okay? So we're going to take these 3 matrices and we're going to find the inverse of each of them. All right? So I'm building these skills till next week where we're going to need all of this to solve a system using matrices. Okay? So it's kind of another kind of thing we're going to have ready at our disposal. So here we go. The first thing I want you to do is I want you to find the determinant. So let's find the determinant of this matrix. So it's going to be 4 times -6 minus 10 times -3. So that's the same as -24 minus a -30. Now, when I do minus a -30, what is that going to become? It's going to become addition. All right, so what's -24 plus 30? That's 6. Okay? So far, nothing new. Right? We did this 2 days ago. All right? Now, let me show you what happens when you find the inverse. Okay? So to find the inverse, you're going to put this little symbol there. Do you see that -1 in the exponent? By writing that, you're telling whoever's reading this that what you're going to find is the inverse to matrix A. So this means we're going to find the inverse of that matrix. So once you do that, you're going to do 1 over the determinant. What did we just find the determinant was? 6. So put 1 over 6. Okay? Times, I want you to draw another matrix. Now this is the hardest part, okay? Here's the hardest part because you got to memorize this. Do you see that first diagonal that you multiplied with the determinant? Do you see those 2 numbers? You're going to switch places. Okay? They're going to switch places. So exactly. And the 4 is going to go where the -6 is. So the first diagonal, they're going to switch places. The other diagonal, this is the hardest part, the other diagonal are going to stay there, but their signs, S-I-G-N-S, are going to be the opposite. So instead of writing a 10 right here, I'm going to write -10. Instead of writing a -3 here, I'm going to write a +3. Now, one way that you can try to memorize that is to write down and think switch ops. All right? This is what it means. So the first diagonal, they're going to switch places. So they switch places. The second diagonal, they become the opposite of each other. All right? Whatever their signs were, they become the opposite. So if it helps, you can try to think switch ops. First diagonal, switch places. Second diagonal, opposite signs. Okay? Now, once you get here, you're almost done. Right? To find the answer, you're going to take all of these numbers that are in your new matrix that you just kind of created, and you're going to divide them by 6. I know I wrote multiply by 1/6, but that's the same as dividing by 6. So watch what I write for the new numbers. What's -6 over 6? -1. All right. I'm going to write -10/6. Then I'm going to write 3/6 and then 4/6. I will accept this as your inverse matrix, but I'm pretty sure Delta Math is going to want you to simplify, reduce these fractions if you can. And you can reduce 3 out of 4 of those. So that -1 stays the same. How can I rewrite 10 over 6? Right, divide, not 5 over 2, right? If I'm dividing by 2, that's going to be 5 over 3. And then hopefully you can do 3/6. That's 1/2. And then 4/6 is 2/3.
Wait, how did we get those numbers again?
Yeah.
I got you. Okay, let me walk you through it again. It's tough. Okay. Are you good on the determinant? You're good on putting it in the denominator there? We did switch places, opposite signs. So that's set up, ready to go. Then I took these four numbers and I divided them by the determinant. So I'm actually going to change my work here. You don't have to change yours. But I'll do it like this, Minerva, to show you that all four numbers divided by the determinant. And then to finish it, I just reduced all of those. Okay? We're going to do two more. Don't worry. It's going to take some time to see this process play out. Okay, let me do number 2. You're good. We're still there, right? Only number 2. Okay, number 2. The first thing you're always going to do when you're trying to find the inverse matrix is to find the determinant. All right, so let's find the determinant. Isaac, do you remember how to start the work for the determinant? Okay. So what's that first number in that first row? 2. Do you know what it multiplies by? Excellent. And then put minus. And then what's going to be my second product? And not -4 and -4, -4 and the other diagonal? -2. Okay? So this is going to be 8 minus 8, which is 0. You guys are going to love when you get this one. Because if you get this one, right, I can actually stop right here. Here's why. If you go back to my first one, if this determinant had been 0, can I take these numbers and divide by 0? No, you cannot. So if you get 0 for the determinant, that means this particular matrix that we just saw does not have an inverse matrix. So you're going to write, there is no inverse matrix. Now on Delta Math, it'll give you a little dialog box that's going to default to say there is an inverse matrix. You're going to have to click that dialog box and just the next one down, click that, which says there is no inverse matrix. You don't even need to do any of that stuff because there's no reason to do the switch places, opposite signs, because at the end of the day, Samantha, you can't divide by 0. So you can stop. You don't have to do all this work because if you get here, you'd just be all your numbers divided by 0, which is not possible. So that's why we just stop and we write, there is no inverse matrix. Okay? So that could happen is why I did that. Let's try number 3. Let's do this determinant. All right. Michael, can you tell us the kind of order to multiply here for the determinant?
Yeah, -7 and -3.
Excellent.
And then 2 and 10.
Excellent. So that's going to be positive 21. That's positive 20. So what is my determinant? It's 1. All right. So I'm going to write down. So it's not 0, right? So I got to keep going, right? Some of us are like, oh, no. Got to keep going if it's not 0. The first thing I do is I do 1 over the determinant. And in this case, Ijoma, you're right, it is 1, which is nice because in the first one I had to divide by 6. But in this one, I'm just going to end up dividing by 1. And anything divided by 1 is just going to stay the same. So this one should hopefully be simpler when we get to the end. Okay? Almost. I'm so close. Last one. Okay, man? Now, remember the phrase switch ops, right? So this -7 and the -3 are going to switch places to be -3 and -7. The 10 and the 2 are going to stay there, but they're going to become the opposite sign. So that 10 becomes -10 and the 2 becomes -2. Now I'm going to do this step just to help your brains, but just know I would never do this if the determinant was 1. But I'm going to divide all 4 of these by the determinant. Do you see why you really don't need to do that step? Right? Dividing by 1 isn't going to change them. So in this case, your inverse matrix is -3, -10, -2, and -7.
So we can just keep it like that?
Yes. Now be careful. Sometimes whenever the determinant would be -1, and dividing by -1 will change them, right? The signs will become the opposite. So the only time where you can do the switch opposite and you're done is when the determinant is 1. That's kind of the only special case. When you're ready, Miriam. Thank you for waiting.